AI model for mentorship. The AI engine deep neural network, DNN, depicted in the image is a powerful diagnostic tool for hospital patients' e-log processing. Welcome to this mentorship module on deep neural network architecture. In this video, we explore how a powerful AI model can transform healthcare diagnostics through intelligent data processing. Stethoscope doctor's point of view. Objective: enhance clinical decision-making using AI-powered diagnostics and treatment planning. Key benefits for doctors. 1. Consolidated e-log input. Receives structured patient data, vitals, symptoms, lab reports, radiology. Saves time by automatically pre-processing data and suggesting diagnoses. 2. Real-time diagnosis assistance. The DNN model interprets patterns across multiple patient signals. Doctors view an AI-generated diagnosis, example high cardiac risk, in seconds. 3. Treatment plan support. The AI suggests a recommended treatment plan visible in the doctor view node. Reduces human error and serves as a second opinion for treatment validation. 4. Patient communication via feedback loop. Doctor feedback rightward arrow to patient ensures clear and timely communication. Enhances doctor-patient trust and personalized care. 5. Decision confidence. AI-backed outputs give physicians evidence-based support. Models like Softmax and ReLU used in hidden layers improve diagnostic reliability. Boardroom/CXO point of view. Objective: use AI insights to improve hospital operations, compliance, and strategy. Strategic advantages. 1. Operational visibility. Aggregated insights from the AI model's doctor feedback rightward arrow to boardroom node help CXOs understand performance trends. Enables real-time KPIs. 4. Treatment success rates. AI predicted disease clusters. Resource utilization. 2. Compliance and quality auditing. The e-log traceability offers full transparency across diagnosis, recommendation, and doctor action. Critical for NABH, HIPAA, and ISO 21001 audits. 3. Resource planning. Identifies department workload and case complexity through AI analytics. Helps optimize staffing and training based on AI-suggested outcomes. 4. Predictive strategy. Using aggregated e-log outcomes, the board can forecast disease outbreaks, readmission probabilities, budget variance for diagnostics and prescriptions. 5. AI governance dashboard. Integration into a live AI dashboard with animation and feedback flow improves CXO decision speed. Supports strategic AI investments across the hospital network. Direct hit video summary flow, based on the Sankey DNN model. Patient data input. Downward arrow. AI layers, H1 rightward arrow H2. Downward arrow. Diagnosis output. Downward arrow. Doctor view, plan. Down right arrow down left arrow. Doctor rightward arrow patient doctor rightward arrow boardroom. Downward arrow. Improved care strategic improvement. End arrow final thought. This elog.mp4 is a powerful mentoring and operational tool, by Pradeep K. Suri. For doctors, it enables real-time, AI-assisted decisions. For the boardroom, it transforms individual patient outcomes into scalable, strategic intelligence. AI model by Pradeep K. Suri. Opening scene, title and context. Scene, input layer, patient features. Narrator. We begin at the input layer, where raw patient data is introduced into the system. These inputs include vital signs, symptoms, lab results, radiology images, and prescriptions. Brain mentor tip. These input features represent real-world signals collected from patients, serving as the foundation for all downstream learning. Scene, hidden layer 1, feature transformation. Narrator. The data then flows into the first hidden layer, where feature transformation takes place. Here, weighted connections and activation functions begin to extract patterns and relationships. Brain math node. This layer uses mathematical operations from linear algebra and basic calculus, such as sigma, wx plus b, the basis of perceptron logic. Scene, hidden layer 2, deep abstraction. Narrator. In the second hidden layer, the network moves beyond surface-level correlations. This is where deeper abstraction occurs, allowing the model to capture nonlinear and complex behaviors in medical conditions. Brain math node. ReLU and softmax functions are applied here, backed by multivariable calculus and optimization theory. Scene, output layer, prediction. Narrator. The final output layer provides the diagnosis. The model classifies conditions such as respiratory illness, cardiac risk, or neurological issues depending on its training. Brain mentor tip. This output is driven by probabilistic interpretation, often using a softmax function to generate the most likely result. Scene, loss function, accuracy measurement. Narrator. To evaluate its predictions, the DNN compares output with actual results using a loss function, a mathematical representation of error. Brain math node. Functions like mean squared error or cross entropy are minimized through differential calculus. Scene, backpropagation, learning loop. Narrator. To improve over time, the model adjusts itself through backpropagation, propagating errors backwards to fine-tune weights and biases. Brain mentor tip. This iterative learning is based on gradient descent and optimization algorithms, central to machine learning. Closing scene, career and mentorship relevance. Narrator. This video model not only demonstrates DNN architecture, it also prepares you for real-world AI challenges. Whether in healthcare, finance, education, or logistics, the core principles remain the same. Narrator, closing words. Deep learning isn't just coding, it's about understanding the flow of intelligence across layers. With this mentorship, you're ready to architect the future. Narrated script, Deep Neural Network, DNN, as a diagnostic tool, mentorship module. To explain the e-log video titled elog.mp4 in the context of an AI mentorship program using a deep neural network, DNN, for hospital diagnostics, we'll provide a professional breakdown from two perspectives. The video titled Deep Neural Network, DNN, depicted in the image is a powerful diagnostic tool for hospital patients, is highly appropriate for a mentorship program on DNN architecture, particularly in the healthcare domain, for the following reasons. Direct hit why this video is appropriate for DNN mentorship. 1. Real-world domain context, healthcare diagnostics. The video uses hospital diagnostics as a relatable and impactful application. Mentors can guide ments to connect theory with practical implementation, focusing on patient data, diagnosis prediction, and decision-making. 2. Clear layered DNN architecture. The DNN model shown includes input layer, real-world medical features like vitals, symptoms, reports. Hidden layers, abstract computation and transformation. Output layer, predictive outcomes like diagnosis or treatment recommendation. This structure makes it ideal for explaining how data flows through a neural network. 3. Mentorship objectives fulfilled. Objective explanation. Architecture awareness. Mentors can explain each layer's role, input, hidden, output, and transitions. Mathematical foundations discuss backpropagation, activation functions, weight optimization. Ethical AI introduce concepts of fairness, privacy, especially in healthcare. Explainability use patient scenario to discuss how decisions are justified. 4. Visual learning and engagement. The animated structure with nodes and flows makes it easier to visually teach complex topics. Animation engages ments better than static slides. 5. Scalability for projects. The same DNN concept shown in the video can be extended to finance, fraud detection. Education, student performance prediction. Manufacturing, predictive maintenance. Counterclockwise arrows button. Thus, ments can adapt the knowledge across domains. 6. Narration ready for LMS or corporate training. The video can be easily augmented with mentor's voiceover explaining each stage. Pop-up tips or highlights at each layer. Branded templates for corporate programs or LMS platforms. How mentors can use it. 1. Start with this video to establish DNN intuition. 2. Break down each layer with whiteboarding or live coding. 3. Assign projects to replicate this model for other datasets. 4. Discuss ethics and responsible AI in real-world deployment. Brain recommended add-ons for mentorship. Add a caption, AI model by Pradeep K. Suri. Include mathematical branches at each layer, example calculus, linear algebra. Develop exercises. Explain the role of hidden layer 2 in this video. Modify this architecture for predicting diabetes progression. Thank you for watching.